Okay, we're going to do some sigma notation. We're going to show how we can algebraically calculate um, quite a bit of these sigmas or summation problems. So remember the Greek capital letter sigma, this big E looking thing, which we've seen this before. A little bit in Algebra 2, but also you see this. This is when you add things up, like on a spreadsheet. If you've ever worked with Excel or in Google Sheets, that's the big button that says, hey, I'm going to add a bunch of things together. So if you remember on the bottom, it tells you where to start. You're starting with an n equals 1. And then the top tells you which term to stop at. And then over here tells you what how to get each of your terms. So in the most basic setting, if you're going to do something like this means start with the first term, go to the fourth term. How do you get your terms? You take your term number and square it and then subtract 3. 1 squared minus 3. That would be the first term. And then you'd add on the next one. Now I'm going to put a 2 in there. 2 squared minus 3. And then you add on 3 squared minus 3. And then you add on 4 squared minus 3. Now this is a bit cumbersome, yes, because now I get 1 minus 3, negative 2. 4 minus 3 is 1. 9 minus 3 is 6. 16 minus 3 is 13. And we add those things up. 13, 19, 20, 18, and I get 18. And, same idea here, except now let's plug in 3 to the 4th plus 1. So it's starting me with a B of 4. That means put the 4 in there. And then I put a 5 in there. And then I put a 6 in there. Whoops, 3 to the 6 plus 1. And then I put a 7 in there, and they're telling me to stop. And I could go through the whole process of figuring these things out if I so wanted to. And I can get, I think it's 3244. Okay, so this is a bit cumbersome. Some of you know there is a key in the calculator. That didn't used to be the case, where we can plug these things in and we can solve them. Okay, we're not going to make you do problems like this. We're not going to make you do them like this. You can't put this into your calculator though, because it's going from 1 to infinity. So if you think about this one, this is 2 times 1/3 to the 1 plus 2 times 1/3 to the 2 plus 2 times 1/3 to the... I could be here forever, right? So this is 2/3 plus 2/9 plus 2/27. Well, if you take a look at this, this is really a times b to the x, isn't it? And so you can actually do this one with the first term is 2/3 and the common ratio is 1/3. So you can do, this is a converging series. So sometimes you can do these as converging series and get 2/3 divided by 1 minus 1/3, which will give me 2/3 divided by 2/3. Hey, all these things add up to 1 whole. So that one converges. So it's like, well, that's not bad if I can get it into my converging series, but these are not converging series. These are partial sums that we're finding the sum of those terms, and that's a little bit cumbersome. So let's take a look and see if we can find some better ways to do this. If you had to write one, first of all, you need to figure out how am I getting these terms, and where am I starting and where am I ending? 15, 24, 35, 48, up to 143. That's a little bit awkward. But it looks to me like this is 4 squared minus 1, 5 squared minus 1, 6 squared minus 1, all the way up to 12 squared minus 1. So you can do this as number squared minus 1. And you can start with the 4th term and you can end with the 12th term. So if you had to write one, that's kind of how you want to put them together. That's not the only way to put this one together, but it's probably the easiest way to put it together. Okay, let's get to the next page, which is really the nuts and the bolts and going to be very similar to what you're going to do on your worksheet for today, the summation worksheet. All right, let's see here. Okay. All right, so a couple of rules. We can break these things apart. Um, we can break them apart a few different ways. First of all, if there is a whole number, if there is a coefficient, if C is a coefficient, we can pull it out front and find the sum and then add it on. So for example, if you have something like m equals 1 to m equals 7 of 5m squared, you are allowed to pull the 5 out front and do from 1 to 7 of m squared. So first it's kind of like factoring out the greatest common factor, because if this is 5 times 1 squared plus 5 times 2 squared plus 5 times 3 squared plus 5 times 4 squared, I can just do the 1 squared plus 2 squared plus 3 squared plus 4 squared and then multiply the 5 on. So you are allowed to factor, and you want to factor out a coefficient. So this means we can factor a coefficient out. Okay, so then maybe we want to do something like the next one says if I'm going to take this the summation, the summation of a sum, we can split it up and do this one and then do this one and then add their results together. So an example of that might be, I'm going to go from h equals 1 to h equals 9, and I'm going to do 2h plus 5. So I'm allowed to split this up, and then I'm going to use the rule from over here. I'm going to pull the 2 out front, get an h right there. H equals 1 to 9, and then I get a h equals 1 to 9 of 5. Incidentally, if this was going from 1 to 9 and that each term is nothing but a 5, aren't I going to add 5 together with itself 9 times? What is 5 times 9? Well, it's 45. 5 plus 5 plus, yeah. Oh, interesting. And this one here would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Take that answer and multiply by 2. Huh. Interesting. So the moral of the story is we are allowed to factor a coefficient out front, and we are allowed to split up if we are adding or subtracting. So here is how we're going to show our work on these guys. We're going to use these following examples. The first one I just talked about. The first one is the constant. So let's do, instead of going to 9, let's do from 1 to 4. And let's say that the constant was 5. Well, that means the first term is 5, the second term is 5, the third term is 5, and the fourth term is 5, which means we end up with 5 times 4, which means we end up with 20, which means when I just have a constant, if I'm going from k equals 1 to n, and I just have a constant out here, a number, so this is the constant series, no variable, I can just take n times c. Okay, isn't that great? And then if I went from, let's say, a linear now, that means to the power of 1. If I go from k equals 1 to k equals 6, so this is an example, 1 plus 2 plus 3 plus 4 plus 5 plus 6. Well, isn't this just an arithmetic sequence where we have the number of terms is 6? And the first term is 1 and the last term is 6. Oh, so I can do 6 over 2 times 1 plus 6. And I get 21, which means for a linear term going from k equals 1 to n, I can do n over 2 times 1 plus n. Yeah. Which is also known as, if I kind of distribute this, I can also do n times n plus 1 divided by 2. That's probably going to be the best way to do it. Okay? So because of what we know about the first plus the last, and the first would always be 1 in this case, starting with the 1 at the bottom, and the last is whatever's on the top there. We can distribute that in, and we get this. Okay. And then the bottom one, we're not going to do an example because this is a humdinger. So let's just do the formula. So the quadratic, okay. a quadratic. Whenever I have k equals 1 to n of k squared, it's n plus 1 to n plus 1 divided by 6. Okay, so you want to have these three: quadratic, linear, and constant. These are the formulas that we're going to use to show our work on our worksheet. Okay, so let's take those. I got to erase them because we're going to go down here. And what we're going to do is we're going to create, using those rules from the top, we are going to create these situations where we can use those formulas. So the first thing I'm going to do is I'm going to separate this into three things. I'm going to take the 2 out front, and I'm going to go from 1 to 5, and that's going to be an m squared. There's the 2m squared. And then I take the 3 out of this one, and I'm going from 1 to 5, and now I have a linear one. And then I take the 2 as a constant, and I go from 1 to 5 of 2. So now I'm going to do the quadratic one, the quadratic. So this is going to be the quadratic, okay? That's a quadratic. I'm going to use that equation from up top. And then this one is going to be the linear one from up top. And then this one is going to be the constant one from up top. And we're going to plug our numbers into the formula, and then we're going to calculate it out. I'm going to start with the quadratic. So we're going to have 2. The 2 comes out front, and then I have n is 5 times n plus 1. That's 5 plus 1. That's 6. And then 2n plus 1. That's 10 plus 1, or 11, all divided by 6. And I like to show my work like this, okay? So if you look at the formula that's right up there, that formula for quadratic was n plus 1, 2n plus 1 divided by 6. And my n was 5. So I take it from this number. Here's the m squared. That's what tells me which one I'm going to use. There's 5. 5 plus 1 is 6. 2 times 5 is 10 plus 1 is 11. Now I'm going to move to the linear term, and I get plus 3, and that one was n times n plus 1 divided by 2. Again, the linear term was n plus 1 divided by 2. My n was 5, so I put a 5 there, and I put a 5 there. The 3 is out front. I'll handle that in a minute. Finally, I'm going to do the constant term, which is simply 2 times 5, because it's 2 plus 2 plus 2 plus 2 plus 2. Is that 5? I don't know. And I get 10, or I'll get 10 there. Okay, now I'm going to put them together. Now, and I like to do this because, watch how easy. 2 times 5 times 11. 10 times 11 is 110. And then I like to do, this is 6 divided by 2 is 3 over 1. 3 times 5 is 15 times 3 is 45. And then plus 10. And I get 110, 155, 165. Okay, so this is how we're going to do these problems. We are going to show our work with how to algebraically do using these three formulas that we have and those couple of rules for taking things apart. All right, let's do a couple from the worksheet. This worksheet is a part of your homework. Okay, I gotta find the worksheet. Just a second. Okay, so let's take a look at a couple of these. You need to show all the properties now. You're showing the properties that we just went over. So like this one is 3 times 4 is 12. Ooh, that was tough. Okay, so you're going to use the properties. Let's go to one of the more difficult ones, and I'll do one of those with you, and then you can finish the worksheet. So this is a linear one, so you use the linear one. This is a linear and a constant one. Oh, look at that one. That looks very similar to the one that we did in the notes. Okay, let's do one of these ones back here. Let's do number 66 on the back. All right, so I'm going to take, and then first I'm going to split up 1 to 4 m squared plus 2 1 to 4 of m plus 1 to 4 of 4. Okay, so I have a negative 5, and I will use the quadratic equation, which is n plus 1, and 2n plus 1, which is 8 plus 1, which is 9, all divided by 6, plus 2. Now I use the linear one, which is n plus 1 divided by 2. And then I use the constant one, which in this case is 4 times 4. And then I would simplify this, and I would go 9 over 6 is 3 over 2, and 4 over 2 is 2 over 1. So I'm really doing negative 5 times 2 times 5 times 3. So negative 10 times 15 looks like negative 150. Next, the 2's cancel out, plus 20. Next, plus 16. Negative 150 plus 20 plus 16. Negative 150 plus 36 is at negative 114, I believe. There we go. This one right here, before you do this one, you need to expand out. You got to expand. So I got 1 to 4, and I have to square the first term, multiply the two terms together and double it, minus 6n, square the second term, n squared. Now you'll split it up and go. Don't be scared of these fractions, because you're going to pull those out front, right? You'll pull the 1/3 out. You'll do the quadratic one for the 1 through 6. Pull the 1/5 out. Do the linear one for 1 to 6, and then you'll do the constant one for 6 and 2. Okay, finish those with showing your work.